A to B. You find that your position is 60 nautical mile outbound from A, 7 nautical miles left of the required track. What is your track error angle? Okay, so let's draw this picture. Let's picture this. So you're flying from A to B. You're flying from A to B. Okay, let's join that. Next, you find that your position is 60 nautical mile outbound from A. That means outbound from A means you're going away from A. So outbound from A, let's say this much is 60 nautical miles. At 60 miles, you are 7 nautical miles to the left of the track. So 7 left of the track. So this distance is 7 nautical miles. Now you have to calculate track error angle. So let's join this. Okay, so track error angle will be this angle, track error angle. So let's label this diagram. Your point, your AB route will be your track or planned track. AB is your track or planned track. Let's name this C, point C. AC will be your track made track made good, right? Track made good. Okay, and the difference between track or planned track, which is your AB, and track made good, which is your AC, is called track error angle. Okay, you were supposed to fly A to B, okay, by following this planned track, but due to crosswind conditions and lack of adequate crosswind correction technique, you have found yourself 7 nautical miles to the left of the original track, which was a planned track, and therefore there is a difference, angular difference between what you planned and what you're getting, and that is your track error. So TE stands for your track error. So now let's calculate this track error. So the formula is track error equals to distance of track divided by distance gone into 60, 60 in the numerator. Substitute the values. Distance of track, this is your distance of track, distance of track. Okay, so that is 7 nautical miles divided by distance gone, this is your distance gone, which is your 60 nautical miles into 60. So 7 into 60 divided by 60 is 7 degrees. So track error is 7 degree. Okay, so this is how you do this sum. So again, a quick recap. You were going from A to B, that was your planned track. A to C is your track made good. 7 nautical mile is your distance of the track. And you have covered, so far you have covered a distance of 60 nautical miles. So find track error, which is the angle between track made good and your planned track. Formula being angle equals to any angle, track error angle equals to distance of track divided by distance gone into 60. Substitute the values correctly and get the answer. Question 2. You are flying from C to D, Charlie to Delta. You find your position is 120 miles outbound from C, 8 miles to the right. Now this, in this case, this is similar sum, but the values have changed and now you have found yourself to the right of the planned track. What is the track error angle? So let's draw this diagram. C to D, join that. So you have covered outbound from C means you have traveled 120 nautical miles away from C. So 120 to the right of the track. So you are right 8 nautical miles to the right of the track, and now you have to calculate your track error. Track error. So CD is your planned track. CD is your planned track. Then let's call this point B. CB is your track made good, is track made good. Okay, and now let's find track error. So track error equals to distance of track divided by distance gone into 60. So distance of track is 8 nautical miles. Distance gone is 120 nautical miles into 60. So final answer will be 4 degrees. So track error equals to 4 degrees. Okay, this is 4 degrees. So 8 divided by 120 into 60 is 4 degrees. So let's go to next question. Question 3. You're flying from E to F. You find your position is 90 outbound from E and 6 miles to the right. What is the track error angle? Same sum, a similar sum. So E to F. You have traveled 90 miles from E. So this much is 90 nautical miles, and now you are 6 miles to the right hand side. 6 nautical mile, and now you are told to find track error. So E and F is your planned track. Then let's name this G. E and G is your track made good, the actual track that you are covering over the ground, that you are traveling over the ground. So track made good. Okay. Now let's calculate track error. So track error equals to distance of track divided by distance gone into 60. So what is distance of track? It is 6 miles. Distance gone is 90 nautical miles. Distance that you have traveled is 90 nautical miles into 60. So that is 4 degrees. So track error is 4 degrees. Okay. Now also you can, in addition to 4 degree, you can also write 4 degree right. Okay. 4 degree right. Right is also known as starboard. Track error is 4 degrees starboard. Okay. Let's go to previous sum. Over here also it was 4 degree track error to the right hand side. So 4 degree right or 4 degrees starboard. 4 degrees starboard. And next over here in the first sum it was 7 degree to the left hand side. So we can say 7 degree left, or 7 degree left is also called fourth. So 7 degree fourth side. Next, let's go to next question. You are flying from G to H. You find that your position is 30 nautical mile outbound from G and 4 nautical mile left of the required track, which is your planned track. What is your track error angle? Similar sum, very simple. So you are traveling from G to H. So you have traveled 30 nautical miles outbound from G and 4 nautical miles to the left of it. So what is your track error? So now, what is GH? Your GH is your planned track or required track. What is G and J? It is your track made good, the actual track that you are covering or traveling over the ground. Track made good. And now we have to find track error angle. So track error angle equals to distance of track divided by distance gone into 60. So what is distance of track? It is 4 nautical miles. What is distance gone? Distance gone is 30 nautical miles into 60. So 8 degree. Track error is 8 degrees. 8 degrees to what side? To the left hand side or port side. 8 degree left or port. Let's go to next question. You are flying J to K, which is a required a track of 0.45 degree. So they have told you, or they have given here, that the planned track direction is 0.45. You find that your position is 80 miles outbound from J, which is your departure, and 4 miles to the left of the required track or planned track. What is your track made good? Okay, now here we will have to find the direction of track made good. Simple. So you're traveling from J to K. Okay, and you are 4 nautical miles to the left of the required track. So let's label this planned track. This is planned track is JK. This planned track is what direction? It is 0.45 degree. 0.45 degrees. Okay. JM, side of the triangle JM, is your track made good, the actual track over the ground. And we have to find the direction of JM, which is your track made good. So to find the direction of track made good, you will first have to find the angle, that is track error angle. Okay, and this distance is how much? This is 80 nautical miles. After traveling 80 nautical miles from J, you have found yourself 4 nautical miles deviated from the original track or planned track. So track error equals to distance of track divided by distance gone into 60. Let's substitute the values. What is distance of track? Distance of track is 4 miles. So 4. Distance gone is 80 nautical miles. So 4 divided by 80 into 60. So it is 3 degree. Track error is 3 degree. Okay. So this is your 3 degree. Now your planned track, pay attention here. Your planned track is 0.45 degree. Now what, and track error is 3 degree. So 3 degree to what side? To the side left hand side. Now the basic rule of navigation is that, let's say this is your north pole, south pole, west and east. Now always all directions are measured clockwise or to the right hand side. Okay, so this is 0, 0, 0 degree. So when you go to the right hand side or clockwise, the directions will change. 10 degree, 50 degree, this will be your 90 degree. Then you continue clockwise, the directions will go on increasing. 120, 150, 180, so on and so forth, up to final angle of 360 degree at the north pole. Okay, in the northerly direction. So when you go clockwise or when you go right hand side, directions increase. When you go anti-clockwise, okay, or when you go anti-clockwise or left hand side, directions decrease. So this is 90 degree. Let's go anti-clockwise. So 90 will become 50, 50 becomes 10, 10 becomes 0. So anti-clockwise or left hand side directions decrease. Clockwise or right hand side directions increase. So same here. Now your over here, planned track was is 045. Track error is 3 degree to the left hand side. 3 degree to the left hand side, right? So track made good will be how much? Track made good is to the left of planned track. So it will be 045 minus 3 degree, which is 0.1 degree. So track made good direction is 0.1 degree because track made good is to the left hand side of planned track or required track. So this is how you do it. Let's go to next question. You're flying from L to M, which is a required track of 220. You find that your position is 45 miles outbound from L and 3 miles to the right hand side of the planned track. What is your track made good? So same question, a similar question. L M. Okay, so L M is given. You are 3 nautical mile right of the planned track. Excuse me. So your outbound distance from L is 45 nautical miles. 45 nautical miles. And you are how many nautical miles to the right of the original track? 3 nautical miles. Okay. And this will be your track error. The error between your planned track and track made good. So let's label this diagram. So LM is your planned track or required track. LN LN is your track made good or the original real the real track that you are flying over the ground in crosswind conditions. So track made good. Okay, now LM, the required track direction is 220 degrees. Is 220 degrees. You have to find the direction of track made good. You have to find the direction of track made good. Now to find the direction of track made good, you must first know the value of track error. So let's find that out. Track error equals to distance of track divided by distance gone into 60. So distance of track is how much? So distance of track is 3 nautical miles. Is 3 nautical miles. Distance gone is how much? This is your distance gone. So distance gone is 45 nautical miles into 60. So 60 divided by 15 is 4 degrees. So track error is 4 degree to the right hand side. 4 degree to the right hand side, also known as starboard. Okay. So let's write this here. Track error is 4 degrees. Track error is 4 degrees. Now your planned track is how much? 220 degrees. So your track made good direction will be 220 plus 4, which is 224 degrees. 220 plus 4, 224 degrees. Why? The track made good is to the right hand side of original track or planned track, required track, right? So when you go to the right hand side, your directions increase. Okay, going right hand side or going clockwise, your directions increase. Going left side or anti-clockwise, directions decrease. And therefore, we have added 4 degree track error to a planned track of direction 220 and obtained 224. With this, we have come to the end of this lecture. We will solve the next 6 questions